moving. Okay, so the majority of this section will be a very broad view of licensed 4G spectrum bands, 4G and 5G spectrum bands, starting with, why do we want to do this, right? What are the advantages? Don't worry if that part is rather detailed, because the last couple sections of this are much shorter. We do have, and we've been actually, UTC's been working, and we've been supporting an activity to survey the needs for utilities. Maybe could I have a show of hands? How many here are representing utilities as opposed? You guys are mostly in the back. Interesting. Okay, but that's good turnout. And then of course we have the vendors as well. Our view is that the 4G, 5G spectrum community doesn't really understand very well yet what the utility and critical infrastructure community needs. The 4G, 5G, they build phones, right? And base stations and all that sort of thing. They're used to quantities in the millions and tens of millions and hundreds of millions, and in some cases billions of units, right, per year. Your applications don't have quite that volume in general, and that's certainly not the high end of that. But nonetheless, it's high value, and we think that the private 4G, 5G network is expanding more quickly than the network for public. It's starting to saturate. So, by the way, this presentation will be available on the UTC website. We'll have also available this presentation on our website, and I think we'll have the video on our website if we do everything right. Sometimes there's a goof. That's part of why Madison is here, to make sure I don't goof. But so I'm not going to read this to you. The critical applications there are on the left. These are the ones that we see most commonly associated with 4G, 5G type networks. And I say 4G, 5G today. These deployments are typically 4G. We recommend when you look at spectrum, you also say, well, what is the plan for that spectrum to either, is it already in the 5G standard, or will it be in the 5G standard? So these are the types of applications that we would encourage you to look at. Pretty exhaustive list. Does somebody have an application out there that they want to mention that is not on this list? If so, please speak up or see me afterward, and we'll get it on the list. It's already a bit of an eye chart here. Our view, though, is that by building a network based on a standard, you have the opportunity to create, I think of it as a field area network, other people have other names, a platform that multiple different applications can run on. And over time, a platform that can expand to support perhaps different frequency bands, additional capacity, upgrades. Someday there's going to be a 6G. We think that the spectrum is a foundation for that. And if you choose to go the 4G, 5G path, as opposed to what I call industrial radio, some people call proprietary systems, you are on a path with billions of dollars, literally, of annual R&D, and therefore you're on a path that you can count on. There will be solutions as time goes on. So we think that's advantageous. So the perspective here is partially, okay, what are the spectrum bands? Spectrum as the foundation, you see the lower left there. But what really does it take to put together the kinds of solutions I was describing before? Well, if you're going the 4G, 5G way, clearly you need standards. So is the spectrum compatible with the standards? Is the equipment compatible with the standards? That's important. You also need chips and modules. And for some of the bands that are available to utilities, chips and modules are scarce, right? So there's not that many vendors supporting these. For other bands, there's been good development, certainly for the public network bands, and we'll talk about a couple that are more public network. Those chips and modules are available in the millions. Not millions of models, but millions of quantities shippable, right? Actual devices. So that is a component. Then once you have those chips and modules, you need base stations as well. Everything else can follow without too much challenge, right? You still need integration services. So There's consulting firms here that can do that. You can choose to do your own integration as a utility. The challenges are significant and critical. They're also, I think it's an example of great jobs, right? Great growth area. We certainly encourage any new engineering firms, new engineering students who are graduating to look into this ability to take the various pieces and integrate it into a solution for your networks. So those, we view, are the 4 pieces that are really necessary. When all of those are in place, the network can be built, operated, and successfully standardized. And I would say there was a time, certainly I've been a UTC attendee for over a decade now. There was a time that the spectrum really wasn't, certainly not 4G, 5G spectrum was really available, that carriers had it, but there really wasn't significant availability of a particularly broadband 4G, 5G network. I think that's changing. I think there are multiple bands out there, and I think that's good news for utilities. You can shop, you can compare, you can encourage us to compete, and we will do so. So it's some of these other pieces that, at least for some of the bands, are not fully there yet. All right, so I talked a little bit about the benefits of 3GPP. This may be a bit of a repeat, but just in the 5G standards, and this is taken out of the 3GPP organization. That's the Worldwide Standard Organization that works on cellular type systems. This is the number of 5G devices. So this is more a consumer-oriented perspective, but in this case, I would view it as consumer leads and this private industry is following, but it's a fast follower, right? We're seeing a lot more adoption of the private standards. So while the consumer space is already 5G, mostly we're in the 4G status within the private network with, definitely a question to ask is, okay, what is, from your vendor of whatever kind, what is the path to 5G? How does this evolve? What does that get? Lots of availability of devices, reduced cost base stations, right? You're spreading this cost among lots of different uses, interoperability, base stations to remotes of different brands, huge scaling potential. I have some utilities that are literally talking to me about goals of putting in millions of endpoints. In the UBBA, Utility Broadband Alliance meetings this year, they have what they call a plug fest. We're going to be demonstrating direct to meter communication. So you can imagine that's a way to quickly get to millions of devices. Typically these are low power wide area networks, but that is a flavor of the 4G and 5G standards. Obviously security is huge. We all are conducting business over our cell phones these days. That investment can in turn be used to also support the kind of security that's needed to protect, our nation's most critical, I would say. What's more critical than electricity? Hard to think of that. Water, gas, all of these systems, we depend upon them every day, and without them, we would not be really secure. Long path to upgradability, and if you choose to operate a system like the 700 megahertz I'll talk about is now part of the 3GPP standards. It's a 4G and 5G standard for a part of a narrowband version of those standards. But there's a number of companies that have already installed industrial radios. There's no obligation for them to switch over. Okay, I mentioned the equipment manufacturers list. So you probably see some of your suppliers. Hopefully those of you who are representing manufacturers will see your names there and your competitors' names. If you're manufacturing 4G, 5G equipment and for the private network space, and your name is not on here, please see me afterward. Don't throw tomatoes now, and we'll be glad to get you on there. Obviously, some very traditional names, some newer firms. As we move towards what's called Open RAN, right? Open Radio Access Network, more and more companies can actually come into this space and build components or full systems by integrating different pieces. We've worked with this company, Pololi. It's essentially a startup, but they were able to build a full system that was operating for JEA quite successfully. There's other similar examples, and I think we're going to see this list continue to mushroom. Okay, all of that is really by way of introduction. Hopefully that provides a broad perspective. I'm mainly here to talk about private network bands, and here are the 6 that I'll be talking about, and kind of an inquiry or a note that there may be a couple other bands that are about to make themselves available in this space. So I'll mention those and see if anybody has comments or suggestions on those. So is there one here that's missing that anybody thinks we should have on the list? I think I can talk about most of them. I can pretend to talk intelligently about all of them. Band 26? Is that what I heard?
Yeah, the only other one.
Okay. Good. We will talk about that one as well. And good news is, so Band 26 is currently owned by T-Mobile. It's optionable. Dish has an option to buy it, which extends until September, I think. And their Dish is going to be giving a presentation at the end of the day on Thursday, and I'm planning to go, and then we'll know more about what that's going to be. If there's time, I can give my perspective on it. Okay, and if somebody thinks of another one as we go through here, shout out, and I'll tell you why I think it makes sense to talk about it, or if I don't know anything about it, I'll pretend that I do. All right, 700 megahertz A block. So I'm starting with this one. Most of this goes low to high. One reason I'm starting with this is because it's been a favorite band of mine for quite a while. Our company and Access Spectrum has been selling this band, but also it is the only one on the list that is 3GPP compatible as a 4G, 5G standard, but it's not broadband, right? It is 1 megahertz, 1 megahertz, and there's lots of definitions of what broadband are, but in the 3GPP world, broadband is 1.4 megahertz minimum carrier size and above. This is at least one of the ways they look at it. So this is NB-IoT only. It's owned by utilities and California High-Speed Rail and some oil and gas companies covering about a third of the country. That represents about 10 years work on behalf, mainly by John Kozlowski and to a less extent our company. And so this is being used in 20 plus utilities around the country. Those applications so far are what I call industrial radio, maybe a couple of exceptions that are into the NB-IoT space. But this is a relatively new approval. It happened in March, I think, of a year ago, a little over a year ago, to also be in the 3GPP standards. So I'll talk a little bit about NB-IoT, but things to take from this slide, it's based on 200 kilohertz channel sizes for NB-IoT, and has up to 25 miles or more radius in a non-line of sight environment. So very long range, 25 dB advantage over broadband modulation at the same frequency. So huge advantage. That doesn't come for free, right? Narrowband is really narrowband in this point. We're talking, tens of kilohertz, maybe 100 plus kilohertz, much slower than what a lot of the industrial radios can accomplish. Longer latency. This is really intended more for a kind of an application, metering, line sensing, something where it's not in constant communications. And it can work in battery power environments. Some of the metering makers are interested in this more for water and gas than they are for electricity to take advantage. 10-year plus battery life. So that is the standard. I mentioned this is available in a number of the utilities. So here you can see some of the ones that have acquired so far: Encore, CenterPoint, Portland General Electric, Puget Sound Energy, Northwestern. I'm not listing all of. First Energy has a major deployment. So those are some of the utilities around the country. We expect this group to continue to expand. So this is, as I said, This has been an important band to my company, and I think it's been an important band to the utility industry over the past decade or so, and will be increasingly in the coming years. If you operate in any of the areas that are green, then that means you still have the opportunity to buy this spectrum. We'd love to talk to you about that. John at Access Spectrum has, I'll say, the western 2/3 of that, roughly, if you look at how the map is divided. But we work very closely since the geography doesn't overlap. If somebody comes to me and they need spectrum in John's area, I'll direct them to John and vice versa. And we see a range of uses here. So in a lot of cases, this is what we call wideband spectrum. It's 3GPP calls it narrowband, but they don't really have a wideband category, right? So this is just below the broadband space. So there are field area networks that are supporting major utility operations that use the systems. Salt River Project is an example of that. Great River Energy is an example of that. So it's substantial capacity. It's not up to the broadband speed. Relatively low latency in the industrial radio implementation. Overall has been quite successful. All right, so stay with NB-IoT for a moment. So what kinds of applications? Relatively low speed, talking about sensors, and that can help improve performance of the network, talking about things like methane sensing, managing rooftop solar, a lot of kind of interesting applications, parking type arrangements. And this, what we're seeing is, high growth. So 23% annual CAGR, compound annual growth rate, according to Grandview. Other estimates are in the same range. All right, so I'll talk about a particular example here of how this could make sense. This is really based on an Itron calculator they have on their website, so I encourage you to talk to them about this application. They look at a variety of ways. So one way a smart street light saves money is just that it uses different bulbs, right? LED bulbs, so it's more efficient. Wireless doesn't really have anything to do with that, so that's part of the benefit here. But with a wireless connection, you can turn down the power when it's a time of night or there's not particular activity, and turn it right back up if there is an emergency in the area or if there's a gunshot sensed in the area. So it gives you that control. It allows you to know in advance, typically, whether that LED is reaching the end of its life, to organize the maintenance. They figure that over a 15-year period, that's expected to be the longevity of these systems, almost $3,000 of savings per streetlight. In a city with 500,000 residents, that works out to $109 million. On average, there's one streetlight per 13, 14 people in the country. If you just run that through, that's enough to pay for the spectrum. That's enough to pay for the equipment. That's enough to pay for the operations, just from this one application. And it doesn't have to just be one application running on this system, right? It can be, you can do the parking as well. So while I would say municipalities are, I'll say, even more conservative than utilities in terms of how they work through their decision processing, there's an opportunity in this case. And in some cases, utilities are operating these systems, right? So they could get the benefit out of it. It also, of course, saves huge amounts of CO2, right? Because they're not burning coal or gas or using other kinds of electricity to keep these lights lit. So, example, it's narrowband, but it's still pretty powerful. All right, now we get into the broadband bands. Again, I encourage people to comment as we go through. 600 megahertz has been talked about for the utility space. It's been trialed by New York Power Authority. I'm not aware of any other 600 megahertz operations going on. Most of this was bought by T-Mobile and Dish. It's really not available to utilities. You can talk to them about it. They'll probably want to sell you services as opposed to spectrum. But there is something like 10 or 15% of the country where at least some of the holders, or at least one of the holders in a given area, there were 7 licenses auctioned. At least one of those is an investor. And that investor probably has no real intention of operating beyond what the minimum needed to meet FCC rules. They want to keep it alive long enough to sell it. And we know a lot of those folks. It was one of those types of investors that loaned NIPA spectrum, actually leased NIPA spectrum, leased Nokia spectrum for the NIPA trial. Actually, that was the arrangement that was eventually worked out. And so the possibility is that they're leasing it, maybe they would want to sell it. So far, that hasn't happened that I'm aware of. And when it happens, it's likely to be expensive. So this is 5 plus 5 megahertz, so it's minimum of 10 megahertz. The auction prices, part of the reason that this theoretically could work is the auction prices were not that high. So if those investors would take a reasonable markup from what they paid in a lot of places, rural places mostly, by the way, this is not so much in the urban environments, then the utilities could buy it and the investor theoretically could be happy. So far, the investors are holding out and have not made any of the spectrum available. So I mentioned the NIPA trial. This was about a lot of capabilities, including UAV control. For those who don't know, New York Power Authority is owned by the state. It's a separate entity. They have a lot of generation capability, Niagara River, et cetera. So a fair amount of hydro capability there along transmission lines. Those transmission lines go all the way across the state from Buffalo and down to meet Con Ed in the outskirts of New York City. So it's a very significant operation. It is a G&T, all right? They do no distribution. So they were looking at, okay, great propagation at 600. Even though the power limits are relatively low, they can follow the terrain and get through the trees and that kind of thing. So these are some of the kinds of applications. But in part, even though they're distribution, even though they're G&T, they want their workers to have applications that can go on smartphones and tablets and that kind of thing. So they were looking at some of those kinds of applications. And I think I heard Nokia setting up a drone. I have no idea what spectrum they're using to control their drone. So you did this one at 600. I think you're going to have one in the hall here, right? Do you know what frequency that one runs on, Larry?
Not 900. It should be.
Okay. All right. So 900. Thank you for the lead in. So this is sometimes known as the anteric spectrum. A lot of my former colleagues working on this stuff. Very interesting approach here. So this started out as specialized mobile radio. Much of it was acquired by Nextel. Mr. Bornman and team were quite involved with that. I actually worked on this towards the tail end of the Nextel life. And they've gone to the FCC. They've gotten approval for a plan to relocate spectrum so that there would be a 3 plus 3 megahertz broadband portion at the upper portion of the band. It's a total of 6 megahertz. And they hold pretty much that amount of spectrum around the country in their own licenses. They are, in order to make the broadband available, there has to be relocation with the other operators. So they're working through that process. They've had 4 or 5 successful leases and sales, so significant penetration. And they've made great progress on what I was talking about earlier in terms of developing manufacturing arrangements so that their customers have the opportunity to buy from a number of different suppliers. I think you guys have a presentation as well, and they can probably say it better. Is there anything I missed that you really want me to add?
Always love following you up.
Oh, okay. Notice it is within the tomato distance there. All right, so this is a band I'm most excited about in terms of talking about. Legato is our client. They're offering band 54 spectrum. The spectrum is high power, 5 megahertz TDD. So we feel that time division duplex, right? So it's just one channel. It's not paired, excuse me. But what you can do is adjust the uplink downlink ratio to effectively use the full channel. So if you have a lot more uplink capacity from your sensors, from your line devices, from your meters, and you have downlink, then you're not wasting part of the downlink capacity And we think that's an advantage. This was approved for 4G capabilities 6 months ago. It was approved for 5G capabilities 3 months ago, also CAD-M and NB-IoT. So it's kind of the full suite. There's no issue about whether it's going to be 5G spectrum or not. For fixed devices, it's very high power, so up to 2,000 watts. And this is the IRP, and both the uplink and both from the tower and from the device. Now, you're not likely to use that, certainly not from the average device. Are you going to use that full power? But it does have the capability, even though it's a little, so this is what we call low mid-band, right? Typically, sub 1 gigahertz spectrum has the best propagation. There's no particular stopping point, but it's a gradual thing. And lower frequencies have better propagation. Of the frequencies we're talking about, 600 is the best, and 7, 9, so forth. 1.6 is called mid-band, lower mid-band. So CBRS way up at 3.5 is also mid-band. So very good propagation, or good propagation, maybe not the excellent propagation in the sub 1 gigahertz frequency, but to some extent the ability to overcome some of that with just a little extra power, right? Because you can, if you have some limited number of distant devices, you can up the power on those remote stations. That is for fixed devices, by the way. The mobile devices have a much more normal 4-watt power limit in terms of what they can transmit. It's in good territory, right? So 1670, 1675. If anybody's heard concerns about the GPS signals, those are quite a ways away. There has been some other controversy at Legato about the L-band spectrum that is limited in terms of the power. This has quite high power limits. The radio astronomy service is next to it. They're listening mostly to space. The NOAA, so National Oceanic and Atmospheric Administration, is 5 megahertz away. And then there's an NPRM where the government may auction the license immediately adjacent to band 54. So that means there could be a future neighbor. It could also be Legato, right? As some people think that could be the acquired spectrum. But at the moment, there's really no interference concerns in terms of inbound interference from the neighbors. If you just look at these, none of these are significant high power systems. Okay, I probably already said most of this. So we got the approval for 3GPP, either narrowband, CAD-M is sort of the intermediate speed. A lot of the metering companies are looking at this, or the full broadband. So there are existing operations controlled by Legato. There's no third party that has to relocate their operations. We think that makes it available immediately. I talked about the advantage of low mid-band. In terms of where the carriers are moving their systems, that's become the most valuable spectrum, right? Because they have high capacity. The lower frequencies are definitely good for propagation, but the bigger that cell is, the more you have to, the less total capacity you have across your system, right? Because each cell duplicates the capacity. So in a carrier world, there's an advantage to being at that space. And we think it's a good compromise between those two. There's also a concept that we've talked about of doing a low band for coverage and this low mid band for additional capacity, something to think about. It can be combined, by the way, with CBRS. We have the first base station manufacturer is committed. Is Jay here? Yes, there is. UBIC is there, and we are encouraging others to make the commitment to support this band. There's also a chip maker that's committed, and we think that the 5 megahertz is a good match in terms of capacity. You're buying 5, not 6 or 10, right? So at the same unit price, it's going to be less expensive, and so we think, particularly for that first utility that we sign up, it will be attractive terms. Okay, 2.5 gigahertz is the next band I want to talk about. This is great spectrum, lots of it, relatively economical, controlled mostly by T-Mobile. This is what I worked on when I was at Nextel and Sprint. And I had a great team that worked with me, and they tied up most of the spectrum in long-term deals. And so you're not terribly likely to get this at this point. We did see Evergy. There was a white space auction, kind of the auction of the leftovers in this band for licenses that had been lost or were never issued or that kind of thing. And Evergy got a significant chunk of this. So at great spectrum, I guess, if you can get it, is what I would say about 2.5. Capacity is great. Range is, a step down from what you would have at the band 54. Okay, CBRS is one that's been very much written about. This is from 3.55 to 3.7 gigahertz, controlled by a spectrum access system, of which Google runs one and Federated one runs one, and there are some others that are out there. So that is a database, essentially a series of databases, all interlinked, run by different companies that track the usage. This is a combination of 80 megahertz of GAA spectrum, general authorized access spectrum. So anybody has the right to use it. You essentially, your device connects to the database, says, here I am, I want to transmit at X power, and the database checks, is anybody else there? And either says nobody else is, or there is available space, or there isn't, and may give you a power limit. The power levels are low, right? So the CBSDs are essentially the base stations. The end user devices, we're talking about 200 milliwatts. That's the power of this thing, right? And because of that, the range and the frequency, the range of these devices is going to be short. We think it's very interesting for a plant, a base station, a transportation hub. We think it is an interesting question about whether you would do metering over this, because with all those devices, you're probably going to need a lot of base stations. Worth looking at. We don't really see this as a general field area network kind of a solution for most utilities. What I'd say about this is there's a lot of availability, and we are certainly interested in talking with you. We have 400. So in addition to the GAA, there's a priority access layer, priority access license. We have clients who hold those. They're interested in, some of them are interested in selling, some of them are interested in partitioning those licenses. Because of the nature of the way this works, it's naturally sort of a partitionable spectrum. It was licensed at the county level, and these could be, if you're only serving a plant, right, you could carve out and just get that territory. So it's going to be interesting to see, how that evolves. In terms of what happened in the auction, worthwhile mentioning, so Alabama Power and part of Southern companies, lots of POPs acquired, so major cities in that case. Southern California Edison, even more so, 22 million POPs, right, people living in the space. And I think they spent $100 million or something like that. This is a big investment, and this is a big part of what they will be doing in terms of their broadband rollout. Some smaller quantities, and there were more utilities that acquired. I think we cut it off at something like less than $1 million spent. We didn't include it in the list. So this is definitely part of the utility space. I think we're excited about seeing how this develops. Maybe I'll be proven wrong, and this will actually support a field area network. I think more often this is going to be, areas on a map, but not necessarily the overall market. And it does give the chance to begin operations with less than full coverage, and without necessarily even holding a true license, right? You can operate just under the SAS system. Thank you for viewing Select Spectrum's YouTube channel. Please subscribe to our channel, or if you would like more information on any of these wireless bands, please email info
selectspectrum.com. We look forward to hearing from you.